Hi, my name is Anthony Parks, and I'm an automotive engineer at Fiat Chrysler Automobiles. I'm going to discuss what it means to design cars and talk about some of the things I do in my job. So, I grew up in St. Louis, and I've always been interested in cars. When riding in the back seat as a kid, I would try to name every vehicle that passed by. By the time I was 10 years old, I already knew I wanted a career in the automotive industry. At some point, I asked my mom who designs cars, and she told me that it was the job of engineers. I honestly didn't know at the time what engineers actually did, but I knew I wanted to learn more. Automotive engineers most commonly study electrical engineering, mechanical engineering, or computer science. When I went to college, I decided to study mechanical engineering because I like how broad it is. Mechanical engineers learn to design things and bring them to life. We have to know about electronics and computer programming, as well as plenty of chemistry and physics. The thing that ties all of the elements of mechanical engineering together is lots of math. But don't worry, it's actually a lot of fun. Automotive engineers have many duties, but I'm going to try to quickly outline the process of developing a vehicle. The first step is to define the functional objectives. These objectives lay the foundation for what customers want from their vehicle. One of the many things that I've worked on is designing seats, so I'll use that as an example. A functional objective may be I want my seat cushion to be comfortable during long trips. The next step is to take those objectives and set technical targets. For example, a specification for the seat comfort may be how soft or firm the cushion has to be. Once you know what you're trying to design, you start to develop a CAD model. This is a 3D picture that shows every detail of your new part. CAD models can show how the part moves, reacts to forces, if it interferes with other parts, and even how it will be built or installed at the factory. When you've perfected the part in the virtual world, the next step is to see it in reality. Prototypes are meant to be quick but accurate representations of the part. For our example of the seat, the production foam is actually made by pouring liquid foam into a mold and baking it, kind of like a cake. Unfortunately, you can't create those molds until you finalize all the details of your part. But a prototype can be made by taking a big block of foam and carving it into the exact shape that you need. This process is too slow and expensive for regular production vehicles, but it works well to give you your first real world parts. The stage of validation testing requires you to go back to your functional objectives and technical specifications to determine that they're all met. This includes life cycle testing, where you must simulate everything that your part may experience through the life of the vehicle. For example, the seat has to survive someone sliding across it, getting in and out of the vehicle without being damaged. This is where some of that math comes in handy. Let's say we determine that an average person gets in and out of their vehicle 3 times a day. That's over 1,000 times per year. They obviously want to keep their car for many years. Also, we don't want to only use the average person. We want it to be able to survive the extreme examples, like someone who uses their vehicle for work. There's not enough time to do tens of thousands of tests with an actual human, so we program a robot to do it. The name for the robot that simulates getting in and out of the vehicle is actually called a butt form. We have real people get in and out of the vehicle and we track their motions with a pressure map. We take the most aggressive motion, which is the person who really slams on the seat, and we program the robot to do the same motion thousands of times. This takes a few weeks. If the test isn't passed, you may have to change your design and start again. This testing phase is also repeated once you move from prototypes to the real thing. By the time you get to the point of starting to build full vehicles, the design of your part should be perfect. Unfortunately, it usually isn't. Building a few separate parts for testing is very different from now building entire vehicles. At most Fiat Chrysler factories, new vehicles are finished less than a minute apart. There are a lot of things happening and it all happens fast. Because of this, you may discover new issues. Maybe the person who installs your part is having trouble maneuvering it into place, or maybe you find that they damage a few of them while they're installing them. Even if there are issues with only 1% of the parts, that's a lot of waste when you're building over 1,000 vehicles per day. Once the vehicles are perfectly built and purchased by customers, an engineer's job is still not finished. There are two major categories of engineering changes after a product is launched. One issue is that you had the wrong technical specifications. When the functional objective said that customers want a comfortable seat, maybe you thought the seat should be soft, but customers now think it's not firm or supportive enough. The other category is that you didn't have the right tests. You made sure that the seat isn't damaged when the customers get into and out of the vehicle, but you didn't think about the customer who's a professional bowler and they stretched the leather on their seat when they left their bowling ball on it over the weekend. Yes, we actually do test our seats for bowling balls. Fixing these customer or assembly issues is part of quality engineering. The quality engineers usually stick around for the entire life of the product. The ones who defined, designed, and tested the parts then go back to start the process all over with a new product. The entire process usually takes around 3 years, so by that time, it's already time to start working on the next version of the vehicle. Fiat Chrysler is a huge global company with a lot of brands. As you can see here, we make Dodge, Chrysler, Jeep, Ram, Fiat, and Alfa Romeo. I use the example of designing a seat because it's one of the items that I've actually worked on. There are countless paths that you can take as an automotive engineer. Some of them are powertrain, which are engines and transmissions, chassis, which is suspensions and steering systems, the body of the vehicle, the interior, the electrical system, the infotainment system, crash testing and safety, emissions. The list really goes on. Here are some examples of the positions that I've held in my 7 year career at Fiat Chrysler. I once worked as a quality engineer on Ram pickup trucks. One of my favorite duties of this job was using our weather chambers to test the vehicles in extreme conditions. I could take the vehicle down to negative 20 degrees and bury it in snow, or crank the temperature to 120 degrees and blast it with UV rays. The hardest part was deciding what to wear each day based on my test schedule. I also worked on the first production plug in hybrid system for Fiat Chrysler, which can run purely on electricity or switch to gasoline. I helped develop an algorithm to predict the fuel and oil quality in the gasoline engine. Since the engine isn't running all the time, I had to make sure that moisture didn't build up in the oil or that the gasoline doesn't go stale from sitting. The first vehicle to use that plug in hybrid system was the Chrysler Pacifica minivan. As an integration engineer, I was responsible for creating those functional objectives that I mentioned earlier. A big part of this was getting acquainted with the competitors' vehicles and the features that they offer. That way, I could set our requirements to be better than whatever else was already on the market. I was able to drive home a different vehicle every night. They were all various minivans, but it was still pretty cool. You definitely know by now that I designed seats at one point. I designed the trim, which is the leather or cloth, and the foam for the Jeep Wrangler and Gladiator seats. The one pictured here is a special sports seat that was particularly difficult to design. My current position is an HMI, which stands for Human Machine Interface. I work on the user interface for some infotainment features. The biggest two are the navigation system and voice assistants, which are our vehicle voice recognition, or you can use Alexa, Siri, or Google Assistant. My job is to outline the behavior of the system and how the user interacts with it. Thanks for your time. I hope you learned a little bit more about what automobile engineers actually do.